minus y squared equals 10. Okay, so this is our function now. Remember, it's implicit differentiation. Trying to solve this equation for y in terms of x would be very difficult. But remember, we can still find the derivative fairly easily, just the way it sits. So let's get started. We got 4 terms here we got to find the derivative of. Now, as you get the derivative of e to the xy power, this would be e to the xy times the derivative of x times y. So I can see x times y, that's a product. We're going to have to use the product rule here. Now we'll get the derivative of the rest of the terms. The derivative of x squared is 2x. The derivative of negative y squared would be negative 2y. And remember, we have to leave dy over dx as a factor. Right? And the derivative of 10 is 0. Right, now, the biggest mistake students make with implicit differentiation, they'll forget this negative 10, your constant over here. So you got to remember, you're taking the derivative of every single term. That means you got to take the derivative of the 10 also, which is 0. Now, if you don't take that derivative, a lot of students just want to bring the 10 down and just do the terms that have variables in them. But you got to remember, that constant on the other side, you got to take the derivative of that too. All right, now we're not finished with the derivative yet. We got to find the derivative of x times y. Now that's a product rule. So let's bring the e to the xy down, and let's take this derivative here. So it'll be the first, which is x times dy over dx, plus the first under the second, plus the second times the derivative of x. Now the derivative of x is 1. All right, so it'll be times 1. So I'm just going to leave the 1 off. All right, so it'll just be y, and then plus 2x minus 2y dy over dx equals 0. So read the rest of the problem down. Okay, now so we need to get dy dx terms or factors on one side and everything else on the other side. So, but now first, before you can do any rearranging, we got to get rid of these parentheses. So let's take the e to the xy, and we have to distribute that now inside our parentheses. So e to the xy times x dy dx gives us x e to the xy dy over dx. So multiply to the dy dx term there. So dy over dx plus, and multiply to the y gives us y e to the xy plus 2x minus 2y dy over dx equals 0. All right. Now, once you remove your parentheses, now we can rearrange our terms. We can move our terms around however we want to. I'm going to take the 2 terms that do not have dy dx. We'll move those to the other side, and that will leave us here with the x e to the xy dy over dx minus 2y dy over dx is equal to, now it's a positive x on this side. When you move it to the other side of our equal sign, will be a negative 2x. This is a positive y e to the xy, will be a negative y e to the x times y. So move that to the other side. Now the 2 terms that have dy dx on them, we're going to factor dy dx off. So now this becomes dy over dx, x e to the xy minus 2y equals negative 2x minus y e to the xy. Now, dividing both sides, we have for our final answer, we bring our final answer up here. Dy over dx is equal to this divided by this now. So we have negative 2x minus y e to the xy divided by x e to the xy minus 2y. So minus 2y. Let me just double check my answer now, make sure that's what I got earlier. So negative 2x. We are good. So that's a pretty good differential or implicit differentiation problem. You notice right here with your exponent here, you have to, as you take the derivative of e to the x times y, you got to remember x times y is a product, so you got to take the product. You have to use your product rule to find that derivative as you first get started there. So just got to be careful. So in my classes, we've looked at several implicit differentiation problems. We've reviewed them some this semester, so hopefully this type of problem they'll be able to do. So that's the last example that I've got. So hopefully you've found these helpful. So now I think my classes, we're ready to do our homework. So see you in class.